It's one thing to track the modern changes in Earth's magnetic field. It's another to have evidence of a shift taking place on a much larger scale. One of your most common questions is, what evidence do we see outside the Sun and the Earth? Well, they see numerous nova events and superflares every day in the galaxy. Gamma bursts and type 1 X-ray bursts from pulsars, transient events too, and they are all different. Even in Andromeda, where we surely can't see the small events in any other galaxies, but just looking at Andromeda over time here, these are the biggest of the biggest, the 0.1%, so to speak. Imagine if we could see the small ones and superflares. Now, as we often mention, there are numerous ways they describe things that clearly have nova characteristics. We mentioned some of them a moment ago. They detect these every day, and every star, again, will be triggered differently. Some of those colder dwarf stars, perhaps, only increasing in luminosity. We're going to take the perspective of tracking the galactic current sheet, which you can learn more about at the links below this video. In our immediate situation, we are lucky in that we have a flare star in the closest system to our own and in the general direction of the center of the galaxy, so it would get hit by the galactic current sheet before we did. It's the Alpha Centauri system, where the tiny Proxima is actually quite the beast. It is a known flare star, and that has been known for a long time, decades. However, recently they began detecting the strongest flares ever there. Unlike the decades before, maximum X-ray energies from the system are now routinely hitting 10 times the previous ceiling, with one burst in particular being 10 times higher than that, approximately 100 times greater than the previous ceiling. Now, you can easily search the internet for Proxima Centauri superflare. Whatever your favorite science website is, almost certainly covered it when the news broke in 2018. The superflare itself had actually occurred back in 2016, and with the system being about 4 light years from Earth, that puts the superflare at having occurred around 2012 or so. Was it the galactic current sheet hitting the Alpha Centauri system? We couldn't say for sure yes or no, but without such an increase in activity, one could question a lot, or said another way, how close could the current sheet actually be to our Sun if it hasn't even done anything to the Proxima Centauri star flaring yet? It's one of the things you would see before the sheet hit our solar system, and that is exactly what we've seen at Proxima Centauri. Now, to ask a follow-up question of whether that sheet has begun to affect our system already, perhaps resulting in some of the changes we are already seeing in Earth's magnetic field. Well, we'd have to see changes on the other planets. Even if we couldn't pin them on the galactic current sheet interaction definitively, without that evidence, again, things get a little difficult. But of course, we just recently learned that seismicity is surging at the red planet, and scientists don't know why. Here on Earth, geomagnetism and pre-seismic electromagnetic anomalies even have a textbook today. Now, we saw the supposed to be every 30 years Saturn superstorm arrive a decade early a few years ago, and it was as CMEs from the Sun pounded the planet in the last sunspot maximum, something to watch for again in the coming years as sunspot maximum is set to return. There's record-breaking storm activity on Uranus to complement the brightest auroral activity seen there, also during the last sunspot maximum, and also implicating a change in its magnetic field interaction with the solar wind. Venus has shown tremendous changes in numerous ways, from accelerating winds to glitches in the planet's rotation speed, to extreme brightness, again, during the last sunspot maximum, which we do expect to see again as sunspot maximum returns in the coming years. But the planet that has changed the most is Jupiter. The atmosphere has changed there more than Saturn, Venus, and Uranus combined, and most importantly, its radio signal is changing, something never seen before, and that is wholly produced by its magnetic field and resulting radiation belts. Remember, it's the electrons caught in the magnetic fields, accelerated to high energies, that emit those electromagnetic frequencies, and so to get a change or new, never-before-seen emission in them, you need a change in the magnetic fields. More evidence of a planet with recent magnetic changes, and now, again, I stress, there is no feasible way for anyone to definitively tie either the Proxima Centauri superflare or the planetary changes here we see in our system to the larger magnetic shifts like getting hit by the galactic current sheet. But our own planets in the system and the closest stellar system to ours is where we'd expect to see the changes before the Sun geared up for its own version, and we see them both. Now, let's say you really want to grind my gears, and these two coincidences at our planets in Proxima Centauri combined with the 100 or so in our previous videos on this topic just aren't enough for you. Let's say you need to see the second closest star to us in the direction of the galactic center, having gone off in the years before Proxima. Certainly that's not unreasonable in terms of the previous sign. It's the previous star in line to get hit with the sheet, right? We should be seeing them go off in a line right at us if this theory is correct. Okay, well, that would be Barnard's star, and that one is just 2 more light years away than Centauri, and it was long thought to be quiet and non-flaring in its old age, much older than the Sun and without much juice in the tank, having a rotation speed of 130 days. But that didn't stop it in 1998 from unleashing the first ever detected flare at that star, an intense event that more than doubled the normally stable temperature of its spectral emission. Again, I can't tell you it's the galactic current sheet, but looking back through time, the stars are going off in a line from the galactic center towards us, and our system is showing major signs of change itself. Of note, this is also how a galactic superwave would present at the stars closest to us, looking back towards the center of the galaxy, again going off in that line, outwards towards the Sun. Both mechanisms work, and the only possible evidence you could really ever garner on the nearby stars does tell a horrifying story, sort of like the Chan Thomas version of the catastrophe on Earth. It was not over after the movie and the 23-episode series, and it's not over now. This is our future, and it's already knocking at the door, with the Sun next in line. So we'll keep our eyes open, our diligence steadfast, and keep that goal of making it to the next age fearless. Be safe, everyone.